Hey y'all, so this is section 12.3, infinite sequences and series. An infinite sequence is just a sequence that goes on and on forever and never ends. There is actually a formula for the sum of an infinite series, which kind of blows your mind really, because you're thinking, how can you add something up if it never stops? But anyway, it kind of works like a limit, like it approaches something on a graph. And this is you'll use limits a lot when you take calculus. So this section actually is a good little kind of calculus lesson a little bit. It kind of helps you. You'll use some of the stuff that we're going to learn in here when you take Cal 1. But it sounds like crazy hard, but it's actually really, really easy. I'm just going to start on this page, on your practice page or whatever. It says for each limit, find each limit or state that the limit does not exist and explain. Okay, so basically there's a complicated way of doing this and they work it out and do all this stuff on this page. Please do not do it like that. We are going to do it a really easy way. So I don't know if y'all remember back when we did horizontal asymptotes. I taught you something and we took notes on it. And it had something to do with the exponents. If the top exponent was bigger, it was this. If the bottom exponent was bigger, it was that, etc. Well, we're going to use that rule to find our limit. And I wrote this down on a sheet of paper. So here you go. You may want to screenshot this or something, whatever, but here it is. Okay, so with limits, if the exponent on the top is bigger, the limit does not exist. Okay, if the exponents are equal, it's a ratio of the coefficients. For example, if that were your problem, do you notice how they're both x squared? Like the little exponents are both 2, so they're equal. So the limit is 3/5. You just take the numbers in the front and stick them over each other, and that's your limit. If the exponent on the bottom is bigger, then your limit is 0. So basically pay attention to the exponents. If the top's bigger, if the bottom's bigger, etc. So that's all you do on this first section. So like, number 1, n squared and n squared. So those are equal. So then that means your limit is going to be, I'm trying to think if I actually wrote this out. I didn't actually write this out. That you just make a ratio of the coefficients. Well, they're both 1. So it's just 1 over 1. So your answer is 1 there. Okay. Number 2, they're both equal. So your limit, let's see, n squared and n squared. So your limit would be 4/3. Number 3, n squared is on top. That's bigger than n to the first. So if the top is bigger, the limit does not exist. And so on. You just do it like that. Be careful on number 4. When you full that out, that's actually 3n squared. So if you have 3n squared and 5n squared, of course, those are both the same. So the limit is going to be 3/5. So anyway, that's how that works. So that section's like super duper easy. 7 and 8, write each repeating decimal as a fraction. That's like literally something you do in elementary school. I'm not 100% sure why that's even in here. I mean, it is kind of, but basically, I kind of know, but I won't even bore you with that explanation. Basically, all you do, whatever's repeating, you stick it over 99. Here, I worked it out right here. So 75 over 99, and then just reduce. That's it. And then like on this one, 592, you just stick 592 over 999 and reduce. And that's all. That's it. So that's like crazy easy. All right. The last two, find the sum of each infinite series. There is a formula for the sum of an infinite series, and it's on your practice page, and it's very simple. It's right here. S equals A1 over 1 minus R. Something very important to note, though, this right here, your ratio has to be smaller than 1. Otherwise, the sum doesn't exist. There's not a sum. Like the answer does not exist. So that's super important. Make sure your ratio is less than 1. Okay, so I actually worked out number 9 for us on a piece of paper. I wrote the formula here. A1, of course, is your first term. Your first term is 2/5, so I wrote that there. And then 1 minus your ratio. Well, again, your ratio is, what are we multiplying to get from one term to the next? Well, I already did that. If you multiply by 3/5, that's going to get you from one term to the next. Again, if you're not sure how to do that, take the second term, divide by the first, and you should get 3/5. So your ratio is 3/5. So I think I wrote that. Maybe I didn't. But anyway, your ratio is 3/5. I wrote it right here. So 1 minus 3/5, and then you just work that out and you get 1. So again, just crazy easy. Number 10, I did not work, but I think on that one it doesn't exist, because I think when you multiply, I think you're multiplying by 5 over 2. Yes, 5 over 2 is your ratio there. Well, 5 over 2 is actually 2.5 as a decimal, which obviously is greater than 1. And remember, you can't have a ratio greater than 1 or it doesn't work. So that does not exist. So anyway, there you go. That's 12.3.